All right, I'm here with Tim from Hardware Unboxed, and we're both here in Austin, Texas. So a bit of a trip away from Australia for both of us.
Fun times.
Yep, big flights, a lot of late nights, crap sleeping.
A lot of barbecue.
Yeah, a lot of barbecue. So that's been pretty good.
Yeah.
Why we're here though? Oh yeah, that's probably worth mentioning. We're here for the AMD new Ryzen 4000 series CPUs. So they invited us out to check them out because both of us do laptop content. And yeah, we'll just be answering some of the questions that you guys left for me about the new CPUs. Now that we have all that information available, we should be able to answer a lot of them. The only thing we probably won't cover in this video will be performance, because due to the NDA of this information, we're actually about a month in the past from when this video will be going up, which is an interesting situation. And by that time, in theory, we'll probably have the laptops on hand to test. And those videos will probably go up before this, let's face it, got to get those numbers up. So by the time this comes out, all the performance details will probably be answered anyway. So we'll focus on the other things that aren't performance specific.
Yep.
All right, let's get into it. So the first question that a lot of people wanted to know about was pricing of these new parts, which is fair enough. If you're spending a lot of money on one of these products, you want to know what it's going to be priced at, right? Makes sense?
Yep.
So they didn't really give us any specific information around pricing. So in general, like Intel, they list the parts that they have and how much they cost for like OEMs on their website. So you can get a rough idea of like per unit cost. But with AMD, they don't really do that. And it's kind of hard to get an idea of the actual pricing that, OEMs are going to be buying these parts for.
Yeah, even the Intel parts, they have the listed price, but you never know what sort of bulk discounts they're getting. And I imagine the really big OEMs have fairly significant discounts when they're buying hundreds of thousands of these chips. So,
I'd say so.
Yeah, it's a bit annoying that maybe AMD doesn't have the direct comparison that you can make, but it sounds like from what we're hearing that pricing will be fairly similar to the previous generation. So what Ryzen 7 3750H was priced at is what the Ryzen 7 4000 is going to be priced at.
Yeah, that was the impression I got as well. And, by the time this video is probably out, there'll probably be a lot of laptops with detailed pricing information available. And if there are models like the Asus TUF series that have, like there's an AMD version and there's an Intel version, you can probably roughly compare the price. But it's also going to depend on, I think, how much, so say like Asus or MSI actually want to sell that product for, because if it at the end of the day, if it does end up performing better, you could kind of see it from their perspective that they might want to increase the price ahead of the Intel model to try and make more money on something that's doing better. I mean, it's not ideal if the processor is cheaper and we could be, getting some savings there, but that's just the way it is at the end of the day. Businesses want to make money.
Yeah, it's possible as well that if there's like a unique Ryzen design that's like doesn't have an Intel part in it, they've made it really thin to take advantage of the power savings or whatever, they use HS series, something like that. It's possible that single SKU could be priced really high and much higher than like an equivalent Intel system. So that's possible, but I think in general we'll see cheaper prices than Intel, or at least equivalent for a lot of the stuff.
Yeah, I think they kind of need to do that as well to try and, I guess, get the foot in the door kind of thing. Because, it's no surprise, but Ryzen 3000 mobile CPUs, they weren't the best. 4000 seems like it's a good step up. So if they're trying to, get that, I guess, market share, hopefully the prices aren't, too crazy. So that would certainly help with that situation, I think. So the next question was around temperatures. So obviously a lot of people don't want their laptops running hot. So how do the Ryzen 4000 series CPUs compare in terms of heat? That's a good question. But at the moment, they didn't really go into too much detail with regards to temperatures. And it kind of makes sense. Every laptop's kind of unique in that regard, right? Like they've got different cooling solutions.
A lot of variants.
Yeah, exactly. So one of the questions was around fan noise, for instance. Like someone wanted me to ask AMD about fan noise. Like I can't really do that because every single machine is going to differ and there's so many variables that something like that isn't really something I can find out until I get this to test for myself. Yeah,
it does sound like though that the systems are going to try and push the thermal solution as much as they possibly can. There's some new technologies in these Ryzen 4000 chips that take advantage of things like skin temperature tracking, for example. So they have a sensor that's attached directly to your like aluminium exterior or whatever, or aluminum for you US viewers. And then it sort of it can boost up much higher than the rated, well, it goes up to the rated clock speeds obviously, but it can boost higher than normal for longer than normal if you're running in a really cold environment, you haven't been doing a lot of things recently, so then it boosts for longer. If you're coming from a hotter state, then it might boost for a shorter period of time, all up to that limit that the OEM has predetermined is okay for the skin temperature. So I think that's going to be really interesting to see how that differs from OEM system to OEM system. But if that's giving people more performance, I think a lot of OEMs will choose to maybe run their systems a bit warmer to get those boost clocks up for longer.
Yeah, so the way that works is essentially, I was told that in laptops that just have the CPU and the Vega graphics, so no discrete graphics, there's two sensors. So in addition to like the sensors on the chip itself, which is what we've got at the moment, so there's like sensors on the chassis at different points. So performance is really going to also depend on the temperature of the whole system rather than just the internals, which is an interesting idea because you don't want your system to be too hot when you're like touching it, because that's just an unpleasant experience. And yeah, with the if you have discrete graphics, I think they said there were 3 sensors, so another extra data point to get information to make the decisions on how much the different components are going to boost. And I think that's really going to add some challenges into testing, I think, because at the moment it already there's so many different variables already, like power limits and cooling solutions, and now there's just this extra thing like how cool is the keyboard area? Is that going to affect like my Cinebench scores?
Yeah, it'll be really interesting to see. I think it's important to mention though as well that these aren't technologies that are designed to reduce performance. It's not like they're putting these sensors on and making sure that it runs really cool for you. It's more that AMD's figured out that we can actually go higher and longer with these clock speeds to give you more performance. We saw a demo yesterday with sort of Cinebench running with and without this technology implemented, and to be fair, it is an optional feature for OEMs, so they have the choice to enable STT, which is the feature we've been talking about. And the Cinebench scores for R20, which takes a fair while to run, was still very high after maybe 10, 15 runs. They're still getting almost the performance they were seeing from that first run, which, as we've seen from even Intel chips, AMD chips right now, is not something we really see too much of. It dies off very quickly, so it sounds like a really cool technology.
Yeah, so it was interesting because it was able to obviously keep boosting higher and perform better for longer, which is what you want. So the demo they had there, unfortunately, we weren't able to film, and realistically, it's probably not something we'll ever be able to test ourselves because they had 2 laptops, one with this and one without. So I don't know if there's going to be any situation where for some reason you can buy it with and without. That seems unlikely, or unless the user's given the option to disable it maybe.
It seems like they were using AMD reference systems, hence why we couldn't film it, because they don't want that stuff getting out, I guess. Yeah. But I would imagine that there's just going to be a situation where you have to test an OEM that's chosen to use it and an OEM that's chosen not to use it. And from the sounds of it, with STT version 2 in these Ryzen 4000 processors, it's easier to implement that feature. They've made it less complicated for OEMs, so more likely for them to use it. And I think we'll see a lot more laptops with these really long boost durations, which will be much better for people overall.
Yeah, so in short, better performance, but temperature's probably still going to be up there, which makes sense. Like if you're selling a laptop, you kind of want it to perform good compared to the competition. You're not going to want to kneecap it just so it is cooler for people that are paranoid about temperatures. If you want to do that, most software like options that OEMs provide give you the option of turning down to different profiles, which will limit power limits. Yeah, exactly. So you probably have options to do that, but I think for the most part, this is a pretty good choice because more performance, more better, right?
Love that, more better.
Yeah. So one of the other areas a lot of people were asking about was battery life. And lucky for you, AMD spent quite a lot of time going into details on all things battery life related, which kind of makes sense. Laptops are meant to be portable. I mean, I only use mine most of the time on power to get good performance, but they are designed to be portable. So, what sort of improvements did we see with battery?
Ooh, lots of stuff, lots of cool demos. It sounds like we're getting benefits from really 2 main areas with these chips. There's firstly the benefits from the APU itself, which they're claiming around a 20% improvement. And of course, that is including the extra performance that you get. So it's not like 20% better at the same level of performance as the previous generation. It is the full performance of Ryzen 4000 plus 20% extra battery life. So those 2 things combined are certainly very impressive. And then on top of that, AMD's made a big commitment to working with OEMs to use low power components outside of the APU. So whether that's 1 watt displays or lower power SSDs was a big thing they were talking about, really optimizing all the components so that you don't just get the 20% from the APU, but potentially another 20% from using a lower power display, lower power memory, lower power SSD. So yeah, those are the two main areas, I think.
Yeah, and there were a few other, or quite a few, actually a lot of different things they talked about. So there's other things like just with the new 4000 series processors, like lower idle temperatures. It's faster to like swap to CPU off states. Just basically all these things that add up to improved battery life, which I think is great to see. I mean, obviously we need to wait and test them and do some battery life tests, but it's sounding like it's pretty good and they've taken it into consideration.
Yeah, especially for the U series, I think the 3000 series was perhaps a bit underwhelming there for the battery life. A lot of, you see users complaining that not really getting what they were expecting. At the same time, I think a lot of people suffered from those U series parts being in lower end products that tend to use more like your 30 to 40 watt hour class batteries as opposed to premium laptops that have 60 plus.
Yep.
So that's hurt them. But it sounds like they've really been laser focused on this area as a really key concern for them. And the numbers that we've seen comparing 4800U versus Ice Lake look pretty good, at least from what AMD is saying.
Yeah, so we of course have to take their numbers with a grain of salt. But again, performance details will probably be up by the time you're seeing this anyway.
That's right.
So one of the other questions I got was, are we going to see these AMD CPUs paired with higher tier GPUs? Which is a good question because right now at least, again... In February at the moment, in the past, who knows how things will change. At CES at least, the highest tier graphics that we saw on NVIDIA's side was the Asus Zephyrus G14, which has the RTX 2060 Max-Q. Quite a mouthful there.
Yep.
And then on the AMD side with Radeon, they've got the 5600M in the Dell G5 Special Edition. So they have also announced the 5700M, but at the moment, I haven't personally seen that listed with any laptops, so I'm not sure when we'll see that or what products it'll be in. But so are we going to see any better GPUs than that? What's the deal?
Well, it sounds like there's no actual restriction. So it's not like AMD's going, you can't put a 2080 or a 2070 with these parts or super products when they come out in the future. So yeah, they're just saying that that'll be possible. But as far as we know, OEMs are probably working on it, but they haven't actually been announced in February at this point yet.
Yeah, so it'll probably happen. But my guess is, if there's new NVIDIA Super Max-Q, whatever the name ends up being.
GeForce RTX Super Max-Q products.
TM.
Yep.
Yeah, assuming something like that comes out in the future, it would make sense for them to hold off maybe like a month or two until there's a new product available. Otherwise, you get into this weird situation where, you might launch a RTX 2070 laptop and then, like a month later, you get the Super Max-Q TM GeForce Special Edition version. And then that product is just like, doesn't sell, or it's just an awkward situation. So I think for the higher end GPUs, assuming there is something new not too far off, it probably makes sense just to hold off a bit, I think.
Yeah, that's right. And it sounded like, at least from the short term, AMD's OEMs were working more on sort of the mainstream volume. They've been putting a lot of emphasis on making sure that they hit the mainstream segment. As you know, AMD tends to target sort of the mainstream price points, getting it into those systems with your GTX series GPUs instead of RTX. So it sounds like they're still working on that quite heavily, but there's definitely still going to be high-end systems from the sounds of it. So it's not like it's going to be just the cheapo options like we've seen from maybe the 3000 series.
Yep.
They're going to be targeting all sorts of things.
Yeah, which makes perfect sense. Like if you're coming into this market, you want to make a product, I suppose, that more people are likely to buy. And realistically, most people are going mid-range rather than high-end. That's just the way it is due to cost.
Yep.
Yeah, so there will be some. We just don't know when.
Hopefully you'll have learnt more by the time this video goes out.
You might know more than us.
Yep.
So another question that I got asked was, is the 4900H a thing? Because at CES, I think they only mentioned the 4800H and 4800HS. So is this 4900H a rumor, or what's going on with that?
Well, luckily for us, we did get that and actually announced for real at the event that we've seen. I think by the time this video comes out, probably a lot of people will have seen the announcement because the NDA will have lifted. But certainly they are going to be offering, another 8-core 16-thread part. It's still the same 8-core 16-thread design, but I think as of right now, we don't know the final specs of the H model. We do know the HS specs, but it's looking like they're going to be, unlocking one of the CUs to go from 7 to 8 and then bumping clock speeds. Sounds like the situation.
Yeah, so the clock speeds were 100 megahertz higher on the base and boost with the HS, which is interesting because the 4900 HS is a 35 watt part, whereas the 4800H is a 45 watt part.
Yeah, so somehow they're achieving those higher clock speeds on the HS model over the H model, which suggests some sort of binning.
Yeah, so I still need to test this stuff, which I've probably done by now, but yeah, it's really interesting because in theory, less power but more performance. So yeah, it does kind of imply that there must be some sort of binning process there in order to get those top performing chips as the 4900 series.
And it seems like AMD has a significant capability to do this based on what we've seen with the desktop parts, 3900X versus 3950X, for example. You get an extra 4 cores for about the same level of power consumption.
Yep.
Same situation on Threadripper. So it will be a bit different because it's a monolithic die. So it'll be really interesting to see exactly how the binning goes on that larger chip, whether there's more or less variance.
Yeah.
So it'll be, who really knows at this stage, but it sounds like that's how they're able to achieve that sort of part, which, yeah, interesting, gives better benefits for consumers.
Yeah, and it'll also be interesting to see how what the 4900H ends up being spec'd at, because we weren't given those specs at the moment, and that's a 45 watt part, so 10 watts above the HS. And as I said just before, the HS is like 100 megahertz higher than the 10 watt higher 4800H. So if you have the 4900H at the same power, like,
who knows what's possible?
Yeah, it could. But maybe they don't even know what's possible. That's why they couldn't.
Yeah.
They haven't locked it down yet. And they couldn't tell us.
Yeah, I think as well that we're not just getting the clock speeds with the HS model, which I found really interesting to hear about, was that, NVIDIA's doing a lot of validation for parts like the 4900HS and 4800HS to make sure that, consumers are getting really high quality systems with high quality components.
Yeah, so that was something that I also wasn't aware of going into this, was with the HS CPUs. At CES, they basically only seemed to pop up in the G14, and at the time, it was basically just like, oh, it's 10 watts lower, but it's still a 4800, so still 8 cores, 16 threads. And it was kind of implied at that point that it was just a lower power limit because, the G14 is a thinner, lighter 14-inch machine, which kind of makes sense. You can't go too powerful.
Crazy.
Yeah, you got to keep it fairly moderate. But apparently, there's a bit more to it than that. So,
yeah, it sounds like it's going through to like your screen. Again, it's like what we were talking about previously with, AMD choosing to work more closely with these OEMs on battery life by improving components throughout the system. It sounds like for the HS chips, they're only going to give HS validation to OEMs that are using high-end components and high-end efficient components, so that you get the benefit of both the better binge chip at 35 watts plus the efficient SSDs, efficient displays, and AMD's going through and choosing a whole bunch of parts that fit that sort of program. It'll be interesting to see how that goes, how well AMD chooses these components, whether they're making the right choices. That'll be hard to see until we get more OEM devices, but it was really interesting to hear about that, something that we hadn't seen before.
Yeah, it's like pretty much almost as if it's like going to be its own ecosystem. Like there are other considerations as well. Like they want to make sure the thermals are in check before allowing an HS chip to go into one of these machines. So there's just like all of these nice features that you would want as someone buying a laptop that it looks, or at least it sounds like AMD are kind of enforcing if companies want to actually use this chip.
I think part of that is because we've seen AMD get burned a lot with the OEM interactions that, an OEM just buys a Ryzen chip, like maybe a Ryzen 3 U series part, they put it in like a really crappy design, and then suddenly people have this bad opinion of the Ryzen products, and maybe they're not as incentivized to upgrade to like a Ryzen 5 or Ryzen 7 model in the future because they've bought this really crappy OEM system. So it sounds like across HS for sort of your gaming products, and then the integrations that they're doing with the U-series stuff, that they're trying to stamp that out as much as they can, and we'll see a lot more closely worked designs for these things, which Intel already does. They already do a lot of that, and I think AMD's now sort of stepping up with that sort of thing. Yeah,
and with the 4900H, the HS, and the 4800H, they're all 8 core, 16 parts, so there's 3. And that's quite interesting because on the Intel side, we only have the i9s with the 8 cores, 16 threads at the moment, and they're all 45 watt parts. So, I've only ever seen those in much thicker, more expensive machines.
Yeah,
or the muscle books, as they call them.
Books.
I don't think I've ever actually said that name, so...
Yeah, it's a shocker.
Yeah, let's go back to pretending that one doesn't exist. But it's really interesting, especially I guess this is probably getting away from the original question now, but the U series bit with the still 8 cores, 16 threads, but 15 watts. So being able to get what was traditionally in the past only available in those, I'll say it again, muscle books in the slimmer machines. Really interesting.
Yeah, I think it's unlikely that the 15 watt part is going to perform as well as Intel's 45 watt 8 core part, but from the numbers that we've seen, it sounds like even in 15 watts with 8 cores, they're able to get up to the H series type performance that Intel is providing with, say, your 9750Hs. I mean, it's based on Cinebench scores and stuff like that, which is how representative is that across a whole range of workloads. But certainly the performance they've been showing is much higher from their 8 core 15 watt part compared to anything Intel's been able to offer. Even there's the 6 core, the 10, 7, 10U. 10.7, 10U. The guy on stage for AMD was nailing those Intel product names when
he's done his research.
Yeah, I know. Ooh, he practiced.
I get word salad every time I have to re-record it. Yeah, great names there. Anyway, yeah, so in short, 4900H and HS are processors that are coming.
Yep. All right, so Jared's passed off the question asking to me for this one, which is, a bit of fun. Apparently you got a bunch of questions about undervolting, if I'm right, and sort of how that's going to go with Ryzen 4000. So you asked a lot of questions about this in some of our sessions. So what information have you got, Jared?
Yeah, so apparently, I guess a lot of you are interested in this because it was a really high upvoted comment. So yeah, in the past, as a lot of you know, I do undervolting on the laptops I test, which have mostly been Intel-based machines. So, I either use Intel XTU or throttle stop to lower the voltage, which, generally helps improve either performance or temperatures, sometimes both. So, as an enthusiast, it's nice to have those options if you want to get some extra performance out of your machine. Because occasionally in Cinebench R20, it's pretty common to see 200 to 400 points extra in multi-core, which is pretty significant improvement, really.
It's like overclocking your laptop, just in a slightly different method of doing it.
Kind of, yeah. I mean, some people do refer to undervolting as overclocking. I mean, it feels a bit dirty to me, but I understand you're getting better performance, so it's similar. So what AMD are doing, in the past, as you might know, Ryzen 3000 series hasn't offered undervolting support, so it wasn't something we could do previously. But with this generation, it sounds like, so it's interesting.
Yeah.
So there's good and bad news. The good news is that technically undervolting will be possible with Ryzen 4000 series CPUs. So I was told that they'll be offering the hooks available to developers in order to make these changes. The bad news is AMD isn't providing an XTU style utility that just allows you to go in and do this yourself.
So no Ryzen Master, for example. They're not opening that up in the utilities they have for their desktop.
At least not at the moment. Maybe if there's more pressure. So
get in the comments, tell them.
Get on that. Maybe if there's more pressure, they might do it, but it sounded like they wanted the OEMs to offer this sort of option. So maybe in your ASUS Armory Crate software or MSI Dragon Center software type thing, along with overclocking settings, maybe there might be an undervolting setting. It would be up to them to implement that.
Yep.
I guess a third party, say the guys that developed Throttle Stop, someone could probably come along and do something similar for AMD. Whether or not that'll happen, yet to be seen. But yeah, at the moment, it doesn't seem like AMD are going to be offering that support. And it kind of makes sense based on how they explained it. So, as is typical with AMD, if you've seen Radeon graphics or other CPU reviews, anytime you try and overclock those bits, they don't really go too much further than stock. So
yeah, that's right.
They're kind of already pushing it to the limit, which I think is pretty good because, I don't want to buy something and have to go in and tune it. I mean,
some people like that, but it's good to get it out of the box.
Yeah, I think it's great to have it out of the box. I mean, why do it myself if they can already offer it in the best possible way? That's great. Especially for people that don't know any better, they're going to be getting extra performance that they otherwise wouldn't have been able to tap into.
Yeah, it certainly sounded like they were, with these new chips, they're running the voltage limits much tighter to the sort of specifications than you might get with an Intel part. So there's not as much headroom there. And it sounded like it was right that they test every single chip and they make its own voltage frequency curve, which I guess allows them to sort of put different parts in different places in different parts of the product stack, but also really removes that undervolting headroom. So they're basically just running it really low to begin with, giving you that good performance out of the box and allowing things like precision boost and STAPM and STT, all those boost technologies that they've got to really push up as far as they can go, let it run for as long as possible. I think all that's going to help with that.
Yeah, so it sounds like it's probably going to be quite good out of the box, but potentially maybe for the H series only, there might be some software utilities that allow this, or maybe it might be implemented in the BIOS on some machines.
Yeah.
I'm going to really have to wait and see, but it doesn't sound too good. But at least it does sound like there is some progress compared to 3000 series.
Yeah, it's kind of interesting because we don't really see undervolting available through those software utilities on Intel platforms, do we? It's mostly just you click it and it like overclocks it. So will we really see undervolting in these utilities on AMD? I'm pretty doubtful.
Yeah, it's pretty uncommon. Like I've only had a very small handful of machines that actually have it unlocked in the BIOS by default. But yeah, obviously anyone can install XTU. But a lot of people don't know about it realistically. I'm sure a very small number of people actually go in and undervolt to get the performance. So I think by AMD doing it, as you say, out of the box, I think it's probably a better move for most people anyway. So with the new CPUs, we've still got Vega graphics inside. So is that any different to the previous generation? Because that had Vega too, right? So is it the same?
Yeah. Yeah, it's interesting. It's been, I'm assuming, a very heavily upvoted question that you've got because lots of people were sort of, myself included, I was sort of expecting maybe RDNA will be in these parts, but nope, Vega's still in there. But it isn't the same Vega. It sounds like, again, when I was speaking to David from AMD, he sort of was suggesting that at the time they were developing these Ryzen 4000 parts, they had the choice to go, do they push down the Vega path or do they push down RDNA? And it sounded like the optimizations they were able to do, they have to optimize either one of those paths. And it sounded like the Vega option was the path that would, give the results better, give better results, do it sooner, I'm not sure. Whatever they decided, they've decided to optimize Vega. So it isn't the same, and one of the main things they've been able to do is obviously just put it on 7 nanometers. So in doing that, they're able to get higher clock speeds, which means that even though they reduce the compute unit count down from 11 to 8, they're able to push the clock speeds higher, which gives a significant performance advantage. Then on top of that, it sounds like there's been a bunch of just your standard power like optimization techniques that they sort of, it sounded like they'd learnt a few things from Navi. So it's not a Navi GPU, but they learnt things from that chip that they're able to bring back to Vega for this generation. And then the third thing that allows them to get more performance as well is the shift to LPDDR4X memory. There's a lot of talk throughout the event about these APUs are bandwidth constrained significantly on the memory. They can't use like your GDDR series memory that we see from actual GPUs. So they're stuck with DDR stuff, which kind of sucks. Like DDR4 2400 that we saw with Ryzen previous generations, far too slow.
Yeah, it's a big difference.
So by putting LPDDR4X in, which gives you more than a 2x, I think it's maybe slightly less than 2x bandwidth advantage, maybe it was like 70%, 80%. That's huge, and also allows Vega to perform better than it did previously. So we do see the CUs get cut down. That was a space constraint apparently. Get that die small, but we still should be seeing substantial performance gain. For a U-series chip, like 15 watts, same architecture, well, maybe slight differences to the architecture, and they're getting 20 to 30% more performance. It's not bad.
Yeah, it sounds pretty good. I'll have to test it out and compare it with like Intel Iris graphics and last gen Vega. It's kind of hard for me to test that stuff, unfortunately, because I guess I mostly get gaming laptops, so top of the line discrete graphics. It's really uncommon that I actually get one that's just got like Vega or Intel. But yeah, the performance they showed had it was quite a lot better than like the Ice Lake options.
Yeah, that's right. They obviously have spent a lot of time comparing these chips to, the 1065 G7 in particular, which is the fully unlocked version of, their Ice Lake parts. And, I mean, it's fair to say that with the Ryzen 3000 series parts, the current GPU that they've got already is quite competitive with Ice Lake. So anything they were going to be giving with this generation is just going to be pushing them ahead. And it sounds like they're not just pushing ahead by a little bit, but actually a substantial amount over Ice Lake, which will help them out when Tiger Lake comes out not earlier this year, much later this year. So when that comes out, it sounds like they're doing a lot. They're XE graphics should be in that chip. So when that comes out, we'll expect more performance, and these chips should be still very competitive with that, given what we've seen. And it's only using Vega, so it's still pretty impressive.
Yeah, so it seems like there's a lot of change going on in the integrated graphics space. Like even the Iris graphics was a nice step up over what Intel had before. But of course, Vega is still, at least according to AMD's numbers at this time, a fair bit better. So it could be interesting that we'll get a lot more thin and light machines that are actually capable of doing some lightweight gaming.
Yeah, I think we'll see, or you never know for sure, but there should be fewer options out there that will opt for the MX series graphics, because AMD spent a whole bunch of time saying we didn't extend the size of our die because making these chips bigger is a significant burden on OEMs. So if they can offer like MX 250, MX 330 type graphics in the single integrated chip, that solves a whole bunch of OEM problems, because suddenly they don't need to add that second low power discrete GPU in there, should be more battery efficient. And while previous gen Ryzen Mobile wasn't quite at the level of sort of your MX series chips, that was still, you got a bit more performance out of an MX 250. It sounds like this should be very competitive. Again, I was a bit surprised they didn't compare that in any of the numbers that we've seen. So we haven't seen like Ice Lake plus MX series. We haven't seen like Comet Lake plus MX. But I would expect performance to be similar, which would be very impressive.
Yeah, so it's looking pretty good there. So one of the other questions a lot of people really wanted to know is, how do these new mobile CPUs from AMD compare to the Intel competition? I mean, obviously that's a very good question that a lot of people are going to want to know, because Intel is currently the dominator in the laptop space.
It's interesting that AMD felt confident enough to not just talk about like the flagship parts, like 4800U, 4800H. They actually went through and said, here's how Ryzen 5 performs, here's how Ryzen 3 performs. And I think at this point, we probably will have actual benchmark numbers for at least like the 4800U from the sounds of things. But as far as the AMD numbers are concerned for, say, your Ryzen 5 versus Core i5, it's looking pretty promising.
Yeah, they had, again, a number of different games and like realistic like content creator workloads, that type of thing. Looked like some pretty good improvements there. So be good to see. Yeah,
it sounds like even in some of those situations, the Ryzen 5 versus Core i5 is they able to offer even more performance than, say, at Ryzen 7 versus Core i7. Because you think about it, like if you go from 6 cores to 8 cores, it's less of a percentage gain in cores than going from 4 cores to 6 cores, which is what they're offering sort of your Core i5 versus Ryzen 5. So I think across the lineup, it looks like especially those low-end chips are going to be very, very impressive and really provide a lot more performance in sort of those entry-level to mid-range systems.
Yeah, and with the new stuff comparing to Ryzen 3000, an interesting comment that I heard brought up was with regards to the 3750H. So as you may know, prior to Ryzen 4000, that was essentially their top-of-the-line CPU for gaming, which was 4 cores, 8 threads, performed a bit worse than the 8th gen i5 8300H. So obviously an i7 with extra cores is just going to come along and,
it obliterated it, let's be honest. It was, a bit of a bloodbath.
Then there's also the i9 with 8 cores, but...
Oh, well, AMD doesn't even want to talk about that comparison.
So, with regards to the 3750H, I found it interesting that AMD actually noted that was basically it was an opportunity that they had in the market to move into. So it sounds like they just had the 3700U and they realized they could essentially boost the power limit and clock speeds, and then, hey, we've suddenly got this CPU that we can sell in some gaming laptops.
Yeah, so rather than spending any sort of major development effort, it did sound like it was a quick fix, as opposed to with these Ryzen 4000 chips, where it sounds like they put a lot more effort into the H series. They're sort of gone, oh, look, actually people buy the gaming laptop, so now we've got to, let's actually make H series really compelling and really good. So I think we'll see a situation with this generation that certainly the H series parts will be providing a significant performance gain and really start challenging, the entirety of Intel's lineup, basically.
Yeah, and if it's doing that, then it's essentially making the 3000 series just look a lot lower comparatively.
Yeah, and I think we'll see even the Ryzen 5, was it 4600H? I think that will be much faster than the 3750H, just straight out. Because it's 6 cores, so that immediately gives you a benefit. And then it's Zen 2. So I think there won't be really any chip in AMD's lineup. Maybe U series, that will be equivalent to 3750H. You have to go quite far down the stack to get that level of performance.
Yeah, which is fine with me.
Yeah,
just
good.
Get rid of that. Pretend that one didn't happen.
Yep.
I guess it's probably good from like a. It sounds like they learnt a lot from it. Like it's kind of like, I guess, getting your foot in the door kind of thing into that market.
Yep.
And now they've got a lot more information to go ahead with 4000 series. So
yeah,
hopefully it's a lot better. So those were the top upvoted questions left by you guys for Ryzen 4000. I hope it was interesting. Hope you got some of the answers. If not, there will definitely be a lot of videos coming from both myself and Tim at Hardware Unboxed over the next probably few weeks, probably even prior to this.
Yep.
So yeah, make sure you subscribe to both our channels. We'll definitely have a lot of content on these machines coming in the future, I'm sure.
Yeah, I think it'll be a bit of a process over the next few months to get a lot of different SKUs in, because we've heard here at the event that AMD is providing at least a 4800U system to begin with.
Yep.
Sounds like the 4800H or 4900H, not quite sure, is also going to be available, but
might be a bit later.
And yeah, as we've seen from a lot of even with Intel stuff, Core i5s are hard to come by for testing, at least units that companies are willing to give you.
I've still never had one.
So yeah, I've found it difficult outside of U series to get like a 9300H, and we've found it impossible basically.
Yep.
So hopefully we can get some systems over the next few months that sort of address all the different markets and have some really good numbers, and you'll do plenty of comparisons. I've been telling you at this event, I've been like, you got to smash out those comparisons.
Yeah, I'll probably end up just buying a bunch of machines just to get it done if I can't get them.
AMD.
Yeah. Yeah, so if you got any other questions about Ryzen 4000, I guess let me know in the comments. I'll see what I can do to answer.
Yep, you still reply to every single comment on your videos.
Do my best.
It's very impressive. I've been talking to Jared here at this event. He's like, I've got to go back to the hotel room. I've got to respond to all these comments. I'm like, how do you have time for this?
I just make time.
Yeah.
Cut out that sleep. You don't need it.
You're just a beast with the comments. So yeah, he'll be in there responding to anything. So get in there.
Yeah. So thanks for watching, and again, make sure you subscribe to Hardware Unboxed to check them out.